Hello, I am Andrew Wang, and this is my Physics 2212 Lab 3 presentation. So, to introduce the lab, the goals of the lab was to measure magnetic field and distance dependencies of the bar magnet through the experiment, and also to use computer models to simulate the magnetic field. After, we would compare the observed result and the simulation model to see if they were different, and if so, how different they were. Important concepts and formulas used was the Biot-Savart law and the magnetic field of dipole formula for on-axis and off-axis, and the distance dependence formula. To set up the experiment, first we have to identify the system and the surroundings. The system was the bar magnet and the magnetometer, and the surroundings was everything else in the surrounding universe. To set it up, you would first use the magnetometer app to find the magnetometer chip by compensating for magnetic north. Then you would measure the on-axis magnetic field and the off-axis magnetic field. The observations was that when the magnetometer was far from the magnet, almost no magnetic field was in the X component. However, when the magnetometer was moving closer to the magnet, the magnetic field's X component increased. And here were our results. Using the data, we could calculate the magnetic moment, and using that, we could also find the magnetic fields, which was 7.4 E-5. And then after the lab, we created a computer simulation through GlowScript coding. This code calculates the magnetic dipole moment as well as the magnetic field of the magnet. This code creates the observed locations, and also creates the arrows to represent the magnetic fields. After, you would get this visualization to show kind of what's going on. And then these are results. So the measured off-axis magnetic field and the simulated off-axis magnetic field, they were off by a decent amount. So why was it so different? So many things could be affecting this, and there's many potential sources of error. So some of them could be that other magnetic fields were affecting the measurements. The measurements were inconsistent. For example, the phone could be moved, the surface wasn't flat every time. Many things that make my measurements not the exact same every single time. And the phone app and the magnets will have imperfections as well. The conclusion: so what if you hadn't oriented your experiment to compensate for magnetic north, and instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your result have changed? Well, the results would be more inaccurate because we only wanted the magnet's magnetic field. But if the magnetic north is not accounted for, then Earth's magnetic field will be included in the result too. What if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? The magnitude of the magnetic field would increase because there are more magnets. It would probably double magnitude. However, the direction of the magnetic field will stay the same. And that is it for my Lab 3 presentation. Have a great day, and thanks for watching.